We're finishing up about logarithmic functions as inverses today. So we need to remember what a logarithm is, and then talk about that a little bit, and then work on getting a graph. And then, as we've been doing with all of the other type of parent functions, moving them up, left, right, up, down. We're just not going to do any compressions or stretches on these. We're getting the same basic idea, but you can imagine that the rules would be the same. So we have this log base b of x. So when we thought about this one, log base 2 of x, what does this actually mean? Does anybody remember from Friday, what does this mean if we were to write it out as an equation? It would be, our base is what? Our base is log base 2. 2 to the what power? 2 to the y power equals x. And that's what we were learning about last week for those that weren't here. 2 to the y power equals x. So logarithm is another way of saying that. So what that means is we need to figure out here in this chart, 2 to what power equals 1? Actually, I know you were being silly about that, but actually 0, yes, not negative 0, but 0 actually is the answer. Okay. Because 2 to the 0 power, 2 to the 0 power does equal 1. So 2 to the what power equals 2? 2 to the what power? 1 equals 2. 2 to the second power equals 4. So we have our points now. So what I need you to do is I need you to make a graph to graph the ordered pairs 1, 0, 2, 1, and 4, 2. And then once we draw that, we're going to draw in a nice little curve. So let's do that. And I'm seeing that quite a number of you are doing that. Yes, I gave out a paper. Somehow missed that on your way in. There you go. Okay. You have one? Yes. Huh? Now, those that are doing a good job graphing it, I'm appreciating seeing that. And when you graph it, just like this, the ordered pair, good job, 1, 0, 2, 1, and 4, 2. Okay, here we go. Here's our ordered pair. X is 1, Y is 0. Ordered pair, 1, 0, 2, 1, and 4, 2. And once you put those dots in, if you draw in your curve, and why is the curve like that? Because that's how these values come out. What you might notice is that it looks somewhat like our exponential function that we had before. And the interesting thing about that is really because it does deal with exponents, it's actually the inverse of the exponential function. That's what logarithms are actually, is inverses. Logarithmic functions as inverse. It is the inverse of y equals 2 to the x, because this is 2 to the y equals x. The x and y got switched when you do that. So really, when we think about it, remember inverses, there's that imaginary line that goes through, okay? And so it's the reciprocal of that. So very, very nice that that comes out like that. So you should jot that in. And then we're going to also look at the transformation. So first, make sure that you write in that it is the inverse of y equals 2 to the x. If you remember when we did those graphs, the exponential graphs, it would cross at at 0, 1, and then you had the numbers going up exponentially, and we did all that. So we had the exponential graph that was like this, and then you flip it across the line, and you get the inverse, and the inverse is the logarithmic graph. Y equals log base 2 of x. 2 to the y equals x. 2 to the y equals 2. 2 to the y equals 4. So this goes right around for that with our definition from logarithms. Bless you. So our transformation rules are the same as the transformation rules that we've had before. So what do you suppose happens when you have, here's our parent function. What do you suppose happens when we add 1 to the parent function? It's actually up. Thank you for saying. So it's up because the whole value that we have, y equals 0, but then plus 1 moves it up 1. So what you could do, you could use another color if you want to, or highlight log base 2 of x plus 1. That would bring it up 1. So you put in your up 1s for every one of these graphs, these points, and then you draw in your curve. What happens with this one? Which direction does that one go? To the, I heard somebody say to the right 2, because this one's directly attached to the x, so x minus 2 happens first. So if it happened to be 2 minus 2, it would actually be that one value. So we've got to move everything to the right 2 for this one. So here comes my blue dots, moving everything to the right 2. So our rules end up being exactly the same. We add 1 to the entire logarithmic function and it moves the whole thing up. If we take away 2 just from the x part, then it moves it to the right. And so our graph moves just like any of the other graphs that we had, just like the parabolas, just like the absolute value function from the beginning of the year, just like the exponential function that we already looked at. All of them move in the same basic way. What math? Up through algebra 2. However, they do throw in possibly a couple things with trigonometry, but just a couple of little things, because trig is one of those things that sometimes belongs in geometry, sometimes belongs in algebra 2, sometimes belongs in pre-calc. So it's one of those things that they throw in just a smidge of that. So if you had an opportunity to look up some of that, that would be great. And for those that are interested in making yourself aware of that material, if you look up online on the website and you look up the stuff from Algebra 3, the chapters that are all in the teens, 14, 15, 16, 17, all deal with the trig. And if you made yourself aware of those and you just wanted to stretch yourself a little bit to make ready for that, you could do that and get yourself in a good place. Yes. Are you going to do SAT? I will do that whenever anybody would like. Yep. But people have to show up. So let me just tell you what, I'll come back to that because I want to finish this lesson first. Okay, so on your sheet, we have these, describe the transformations without actually graphing them, just saying what each one of these would do. So where would this one go? Down 7. Good. So write in down 7. Where will this one go? Right 3. This one will go left 4. This one will go not up 1. Down 7. What happens to the 1? Left 1. So it's the same rules that we've been using over and over and over again. The thing that is completely detached from the original function is telling you the ups and the downs. The things that are connected with the x, okay, those tell you the lefts and the rights. I have two lefts here and a right. So just watch out for what those do. The rules become exactly the same. Then we've got some more things to do with the logarithms. Okay, but make sure that you've got that jotted down. Am I still waiting on anybody? No, okay. So inverses. You remember when we did inverses before? And inverses do what? They switch the x and the y. So we switch the x and the y. So I've got my original logarithm here. So what we're going to do is we're going to change this around so we switch the x and y. So here we go. Here's our x and y switched. And this one, actually, the logarithmic inverses are really kind of the easiest ones to do. If we want to solve this for y, all you have to do is use your definition of logarithm, which means that this is our base, this is our exponent, and it equals this number. So 6 to the x power equals y. 6 to the x power equals y. And guess what? Now we're solved for y already. So that is actually the inverse without really having to do too terribly much work. If you understand the definition of a logarithm, and just to review it, 6 to this power, this is our base, this is our exponent, this is our answer, base, exponent, answer. And then what we were doing with those is we were finding out if we were given this number, what this number had to be as an exponent to make it work. So very nice, easy way to find an inverse here. And hopefully everybody's got that. I'm sure everybody's got a chance. Okay, so let's do this one. Let's do the same thing. Let's switch the x and y. And once you switch the x and y, let's do this actually. Yep, bubbles. So here we have this. We're going to switch our x and y. So x equals log base 3 of x plus 5. We want to put it in exponential form. Oops, but not, wait, what did I do wrong? I'm supposed to be switching the x and y. What mistake was made? Where did the y go? Good. The y goes here. All right, I want to solve for y now. But let's put it in exponential form. Yes, the directions said find the inverse. So we want to put it in exponential form. What's our base? 3 to the what power? 3 to the x power equals y plus 5. I want to get y by itself. So yes. 3 to the x power minus 5 equals y. So our inverse, exactly. So there's our inverse. It's, remember our inverse notation, we could also write it as f inverse of x. If this were f of x, I'm going to go back to this one. I'm going back to this one. If this were f of x equals log base 3, I want you to see this other notation, x plus 5. The inverse, f inverse of x, would be 3 to the x power minus 5. So even if you like the notation or you don't like the notation, it is something that you do need to know. The easier way to find it is just switch x and y and solve for y. But the notation is like this. Okay, our quiz for these sections will be a take-home quiz, and it will be due Monday. You'll receive it on Thursday. So. All right. So on Friday, on Friday, we had looked at a certain way of solving by using solving logarithms, guys. But there's another way that you can do it. It's honestly, this way works sometimes better. The other way works other ways sometimes better. So we can rewrite in logarithmic form, understanding that if you have log base b and you have b to the x, then the answer turns out to be x. So it's almost like these b's don't exist because b to the x power equals b to the x power, so the answer is x. So yeah, this way is a little bit harder to get your mind around. That's why we were solving things in other ways.
I kind of understand it. You have b to the x, and if you're gonna put it in that, like I think it's logarithmic form, it's b to the x power, and then it's gonna be log bx equals bx.
Yeah. Okay. Yeah, something like that, yes. So here's another way of looking at this particular problem, okay, would be that the log base b of, or the log base 5 of 5 to the third power equals the log base 5, listen, we're basically doing the same thing to both sides here. We're taking the logarithm with a base 5 on both sides of the equation, just like we're used to doing to both sides anyway. So since 5 to the third equals 125, if we do the log base 5 of both sides, they also have to be equal. But based on this rule, the log base 5 of 5 to the third power equals what number? 3. So that means our answer to this question is that the log base 5 of 125 equals 3. Okay, now that's a little bit more writing and thinking than what we had done on Friday, because on Friday we just simply did questions based on what would be the answer to the question, such as, let me do this, if I had the log base 3 of 9, just to review a little bit, but also to see how it's sinking in here. The log base 3 of 9 equals how much, based just on our simplest way of doing this? I heard a 3, I heard a 2. That it's 2 because 3 to the second power equals 9. How about the log base 3 of 81? Okay, good. Okay, so that's a spoiler right there, but let's, no, I'm just kidding. 3 to the fourth power. Because 3 times 3 times 3 times 3, 9 times 9 is 81, so it's log base 3 of 81 equals 4. So that just kind of flashes back to Friday, what we were doing. Finishing off this lesson, it just says, or use the other method, and the other method is what we were just talking about, where you're figuring out that base to what power equals the other answer. So in this particular problem, in order to go back, we would be saying, okay, the log base 5 of 125 equals, well, that means we have 5 to the x power equals 125. So you're asking yourself, what is my exponent? And 3. So that's a little bit easier to get your head around rather than that log of both sides. But that thing will be ending up becoming useful in some of the other problems that we'll be solving right down the road. So what we're doing with the rest of the period, and I know what we're doing with the rest of the period is we're going to work on assignments, help everybody get caught up, and those type of things.